All right, we're going to pick up here right where we were before. We were talking about the general solution, which is the one that has your constant of integration attached to it. If given an initial condition, and we may not always be, sometimes they just want the general solution, but if they give us an initial condition and they ask for the exact curve, or another term they'll use is particular, then we're going to use this xy point that they gave us to find the exact family member whose antiderivative is this function and it contains this point. So this says when y is 2, x is negative 1. So I'm going to substitute those values in here into my general solution, and I'm going to find my constant of integration. I'm going to find what that constant might have been that went to 0 when I differentiated and found the derivative. So here, 2 equals 1 plus c. If I subtract 1 from both sides, c equals 1. So the exact family member whose derivative function is 2x, or whose differential is dy equals 2x dx, and that exact family member that contains the point negative 1, 2, that family member is right here, and this is called the particular solution. Sometimes they'll call it the exact solution. Again, some terminology that you need to know. So there's some vocabulary. You have to know general solution, initial condition, and particular or exact solution. So there is the answer to that question. And so let's do another example here. First of all, the really good thing for us is that for the AP test, we are only going to concern ourselves with what are called first order separable equations. In other words, when they ask us to find the particular solution or the exact solution or even the general solution, we are going to be able to separate our x and dx and our y and dy terms. Okay, that means they're going to be first order separable equations. So because it can be very involved and complicated, the AP test has chosen only to use those types of differential equations to ask us to find the original function. So these equations only contain the first derivative of the unknown function, and they are such that the variables can be separated when they ask us to analytically find the original function. So I want to show you the step-by-step process on this last example here of exactly what I want to go through your head and what your step-by-step process needs to be. And so anytime that you are given what appears to be a derivative, most of the time the words differential equation are going to be attached to it if it is an AP question. It'll say, given the following differential equation, and then it'll just look like a derivative. It'll say dy dx equals. When you can tell that you are in the context of a differential equation, when it wants the exact solution, the particular solution, when it says to find the function y equals f of x, those are all the ways that they're going to tell you you are in the context of a differential equation as opposed to a derivative function. So if they don't use the words differential equation, you're going to have to use context to figure out this is what you need to do. And if they give you a point in the plane that this original function contains, the derivative of this original function, and they give you an initial condition, remember that, that's what this is called. If they give you an initial condition, then you can find the exact or particular solution, not just the general solution. So when they do that, anytime you see differential equation or you determine that you're in this context, I want you to put some words in your head together. Every time you read or hear or see differential equation, what I want to pop in your head is separate and integrate. Because that's what you're going to do. You're going to separate and integrate when they ask you to find the particular solution or the general solution. So we want to separate in such a way that anything to do with y and dy are algebraically, we can't do any math magic here, the algebra has to work for us, are on one side of the equal sign, while everything to do with x and dx are on the opposite side of the equal sign. So you can see here on this function, if I multiply both sides by y squared and I multiply both sides by dx, then what I'm going to wind up with is y squared dy, algebraically, will equal x plus 3x squared dx. When I multiply both sides by y squared, that y squared and that y squared are going to cancel, and that puts a y squared over here. And when I multiply both sides by dx, that dx and that dx are going to cancel, and that puts a dx over here on this side. That's the separate step. The next step is I want you to show the AP reader that you intend to integrate. So separate and integrate. We want to find the particular or exact solution. So now we're integrating here with respect to y. So we're going to use the power rule for integrals. That's 1/3 y cubed. Remember, we're only going to put our constant of integration over here on this side of the equal sign. So we want the antiderivatives of this function. That's 1/2 x squared plus, if I pop my 3 out front, times 1/3 x cubed, then that term is just x cubed. So there I am on my way. I'm not done yet. I'm on my way to finding the general solution. For the general solution, your answer has to be given as y equals some function in x. Notice here we're not down to y equals, we're at 1/3 y cubed equals. So I need for you to multiply both sides by 3. That 3 times 1/3, that's going to cancel. And then I have 3/2 x squared plus 3x cubed. And now here's where it gets tricky. I don't have 3 times my constant of integration. 3 times some constant is still a constant. That is going to result in just plus c. I know it seems odd not to multiply that by 3 as well, and the constant of integration is going to give you a little bit of headache in this context, but if you'll just be very careful, everything ought to be all right. Just be very careful with it. Now, I want y, I don't want y cubed, which means I need to take the cubed root, and that's going to give me my general solution, which is y equals 3/2 x squared plus 3x cubed plus c, and that quantity is raised to the power of 1/3. This is my general solution. How do I know it's my general solution? Because it's still got plus c in it. This is the family of functions whose derivative is this function right here. All right, the family of functions whose derivative is that function. I'm going to get rid of some of this stuff here and try to leave my general solution there so I can work from that. All right, now we want to keep going because we want the particular or exact solution, and that's where we use this xy point. When x is 0, y is 6. So I'm going to plug those values in here and over here for x. So 6 equals the quantity 3/2 times 0 squared plus 3 times 0 cubed plus c, and all of that is raised to the 1/3 power. Now I want to solve for c. So I'm going to cube both sides. That's 6 cubed equals, this term is 0 and that term is 0. So that's c. So my particular or exact, and I keep using particular because that is a word you will see on the AP test, as well as the word exact solution, the one single member of the family of functions that has this for an antiderivative and contains this point, is y equals 3/2 x squared plus 3x cubed plus 6 cubed all raised to the 1/3 power. Now, all of those steps are going to be involved in finding the particular or exact solution of a differential equation. Remember, when you read differential equation, or you can tell that you're in that context, I want you to think separate and integrate. That's really important because that will help you determine what calculus needs to be done to work your way through that problem. Remember as well, this is a family of functions whose antiderivative is this function, y equals f of x. If you are given a point in the plane, then it allows you to pick from that family of functions. Let's say I have a family of functions that look like this in the plane. Well, each member of that family may have the same antiderivative, but if I give you a point, and this is the point in the plane, then it highlights that this is the one member of the family that they're after. So when they give you an initial condition, you're not going to stop until you solve for C. Okay, this is one and only one function where this is a family of functions that are separate from each other in the plane by a vertical distance of C. All right, so that's it for differential equations. Come to class next time ready to do some homework problems.